Hey everyone, my name is Andrew. I'm a senior software engineer at Codecademy, and today I'll be walking you through a modified version of the Sal Shippers project available on Codecademy's Project Hub. And in this modified version, we'll still be coding it up in Python, but we'll be taking a little bit more of an advanced approach, one that involves classes, lambda functions, formatted strings, and more. So whenever you're ready to take on this project yourself, or if you're interested in checking out some of the other projects we have available, there's a link in the YouTube description below that will take you directly to our project hub. With that, let's go ahead and get started. All right, let's take a look at this project. So we got this guy Sal, and Sal's got a shipping company, and he wants to make sure that every single one of his customers has the best and most affordable experience shipping their packages, because he's just that kind of guy. So in this project, we're going to be building a program that will take the weight of a package and then determine the cheapest way to ship that package using Sal Shippers. And Sal's got several different options for us, including a drone shipping option, which is pretty cool and something I wish was happening more in real life, but I guess we're not there yet. Beneath that, we've got the details of those three plans, which we'll take a look at in a second. And yes, we will be writing this project in Python. So just like any project you'll find on Codecademy, beneath all this introducing of the scenario, we've got a list of tasks, which are essentially the steps that you can follow, and you will arrive at a solution for the project. And if we scroll all the way down, looks like on this one we've got a list or an example solution available, which, spoiler alert, we are about to take a look at. So go ahead and open that, bring it over here. And you'll see that in this example solution, which again you'll arrive at if you sort of follow the steps that are listed here, you'll end up with something that is leveraging conditionals, or if, elif, else statements that have been basically translating the information that you can see in these tables into these conditional statements so that we can compute the cost of each of the plans and then print them out. And that's great, and this is great practice for that. However, one of the things I like about projects is the freedom that we have to solve it in the way that we please. And that also includes augmenting the scenario with our imaginations. I mean, the sky's the limit. We can tack on as many other additional things we want into this scenario and code up whatever we want. And that's what I think we should do for this video. I think would be pretty fun, is to kick things up a little bit on the difficulty level and imagine something that I think might be a little bit closer to a real-world scenario that you might come across if you are an engineer. So yeah, let's dig into that a little bit. So coming back to this scenario, we're talking about Sal and Sal shipping. And, Sal's a good guy. We like Sal. He's trying to find the best price for his customers. Sounds like a great business guy. However, maybe Sal is not the only shipping company available. Maybe Sal's got some competitors that are also trying to offer the most competitive prices to ship goods for their clients. And I think, wouldn't it be neat if we put on our engineering hats and think about, what if we were to build a site where someone could come in and enter in the weight of their package, and we could sift through all the various plans from the various companies, so not just Sal's shipping, but Susie's shipping and whoever else is shipping, and then tell our customer, hey, this would be the best, cheapest plan for you for that package weight. So something basically like what you do when you search for flights. Instead of going to each individual airline, you go to one of those websites, you type in, I'm flying on these dates, and they'll tell you, okay, it's this airline, and this is the cheapest price. Something like that. So yeah, I'm excited. Why don't we go ahead and dive in on that scenario? And right off the bat, I don't think that this if, elif, else would be the approach we probably want in this new scenario. Reason being, I mean, right now we got 3 plans, and that's manageable, and we can solve that using if, elif, else. That's no problem. But if we're hypothetically trying to support tens or maybe even hundreds of different shipping options, then I think hand coding these statements would get kind of tedious and hard for us to maintain. So instead, I think we're going to need to take a different approach. I'm going to go ahead and close that out. And yeah, so what about this different approach? What would we do differently? Well, I think it would be helpful if we could come up with a standardized representation of these shipping plans data. Because if we could come up with a standard representation in the code of what one of these plans contain, then we could write a single function that would compute them for us. And that way we can just pass in however many different plans there are. As long as we get them into that format, we could pass them to that logic, and we could calculate the cost so we know which one's the cheapest. Okay, so to do that, why don't we use classes? I think that this is a good use case of a class. And if you haven't come across classes yet, if they're a new concept to you, don't worry. There's plenty of resources available online, including from Codecademy, where you can learn all about how to work with classes. But that's what we'll use for this scenario here today. So let's create a class that represents the shipping plan. So I think we can call it class shipping plan. And this shipping plan, let's go ahead and write an init method so we can construct a specific instance of a shipping plan, whether that's going to be the ground or the drone or what have you. And okay, so what are the things that we would want to know about a shipping plan? Given in our new scenario that we're trying to be like an aggregator of all these various shipping possibilities, I think one of the bits of information we would need is the company name. So we're going to know, in this case, we've got the Sal Shipping, but could be somebody else. So we want to know the company, and we probably also want to know the name of that specific plan. So it's say name. And then beyond that, now that we know, okay, the company, the name, we want to know the pricing information. And it looks like there are two different types of prices that we're dealing with here, looking at this example here with these three. So we've got a price per pound that varies depending on the weight. And we've also got a flat charge. Now, not all the plans have both of these. Sometimes there's missing one or the other. But in order, again, if we're thinking about how can we standardize this, then we need to account for all the different types of pricing that we might have for any given shipping plan. And right now, since we only got Sal's data to work with, we'll build this around Sal. But if there was some other detail that came up in some other company's plan, we could come back and augment our data model here to include that as well. But coming back to Sal, Sal's got a price per pound, and he's also got a flat charge. And so those are the two we're going to want. And in terms of, we could call this like price per pound, but since these prices, it looks like this varies based on the various, tiers of weight, I think we're probably going to need to represent this in another data structure. And for now, I guess we can call this argument something like, I would go with something like weight tiers, because we're going to have a different tier price based on the weight. And we'll come back to fleshing this out in just a second, but we got the weight tiers, and we also got the flat charge. Okay. And so from here, we're going to do a little bit of boilerplate here. We need to bind in the values that we're passing to this init method. We want to make sure that these arguments, when we initialize a new shipping plan for like drone shipping, for example, and we give it these values, we're going to need to store those values on the specific instance of the plan. So again, thinking about classes being like a blueprint for a house, an actual physical house is built off of a blueprint, and that physical house would be the instance. And so like physically, like the drone shipping plan is a specific example instance of a shipping plan. So anyways, coming back to it, we got self company, we got self.name is going to be equal to the name that we give it, and the weights tiers, similarly, weights tiers, and the flat charge is the flat charge. Okay, so now that we have the shipping plan, the weight tiers seems like another thing that we could represent with the class. So if we go ahead and do that, we create a new one called weight tier. And this weight tier is going to have, let's see, what do we need for a weight tier? Well, it looks like we're going to need some kind of like a min value, like, over 6, but less than or equal to 10. So it's like minimum, like a min of 6, a maximum of 10. And then at that min max, we've got a specific price per pound. So I'll just shorten that. We'll just call this price. And similarly, we're going to need to bind these in. So we'll do self.max and self.price. Lovely. Okay. So now that we have this, I think we're pretty much ready to initialize some specific plans. We've got our generic data structure shape we can use with these classes. Let's go ahead and create some actual plans. So for one, we got the first one is the ground shipping plan. And so we're going to initialize a new shipping plan. And you could go in, as a side note, we could pass in like positional arguments. So we know the company name in this case is Sal's Shipping. Sal's Shipping. And the name of this plan is going to be ground shipping. And we follow basically the argument order. Company is the first one, name is the second one. But in a real-world application, oftentimes you'll find yourself initializing instances of classes in a different file than the one where you've maybe defined it. Especially, again, real-world applications have thousands of files. and it's easy to kind of get a little bit turned around when you're coding or when you're reading through existing code. If you imagine this being a completely different file, you might forget, okay, what was the first argument supposed to be, and the second one? Like, you can see the values, but maybe you forget what they equate to. And a way to get around that, a good habit to get into, is to use named or keyword arguments. So instead of just relying on the positions, we could do company equals. And that way, even though we could still keep the same order, but now it's more explicit. When you read this code, you see this code in isolation somewhere else in the code base, you know, okay, that's what this value is tied to. So I say the name is ground shipping, and then we need some weight tiers now, weight tiers. And since weight tiers, we've got a bunch of them. We've got 4, it looks like. We're going to need a list of them. So we're going to list them out. The first one is a 2 pounds or less. We'll go ahead and make a new weight tier. And the min here, in this case, if it's 2 pounds or less, there really isn't a min. So instead, we could just do none. Say min is none, max is 2, and the price at this tier is $1.50 per pound. So I'm going to go ahead and copy paste this, save us a little bit of some keystrokes. There's 4 of these. So now we just update the rest. We've got 2 pounds, maximum 6 is going to be $3. And then 6 to 10 is $4. Lastly, 10, it says over 10, so there is no maximum. So minimum of 10, maximum of none. Now we're at $4.75. $4.75. Awesome. So one thing I also like to do is print things out just to double check to make sure, okay, did I make a typo? Did something not go right here? We can go ahead and print out on this ground shipping plan, which just double check. Is just say, what's the company? What is the name? And oh, I am missing one thing already. Forgot the weight tiers. We need a flat charge, which is $20 here. So we'll go ahead and add the flat charge equal to 20. Okay, and then why don't we print that out? So what is the ground's flat charge? So if I run this, looks like we do have an error. I made a typo. Price 3. Price equals 3. That's better. So here's south shipping. It's the ground shipping option. It's got $20 as the flat charge. That all looks good. Cool. So I'll delete this, and we'll just fill in the other 2 plans that we know about at this time. So it's still south shipping. This one is going to be the ground premium, so I'll just call this premium. And this is ground shipping premium. And in this case, we actually don't have any weight tiers. So instead of passing in a list, why don't we just pass in none? We don't got no weight tiers here. And the flat charge is actually going to be 125 in this case. Okay, cool. And we only got one more. Paste this in here. We are going with the drone shipping now. This is now drone shipping. And we do have some weight tiers, and thankfully they do follow the same min and max. We just need to update the prices at each. So now this is going to become $4.50. This one is going to be $9. This one is $12. And this one is $14.25. Perfect. And the flat charge is 0. So we could write 0 here, but I'm going to go ahead and just say none. There is no flat charge. Okay. So we've got these 3. We've got our data model. We've got our specific data details that we've filled in on. We have some instances of this shipping plan class. Now what we need to do is, given this standardized model, we need to compute the cost for a given weight. And now we could do that. Let's go ahead and start weight at 1 pound. We could do a standalone function. We could say something like calc cost, where we take in the weight and then also like some kind of a shipping plan. And then we could do some logic inside of here. But I think it's nice to keep things close to, keep the logic that relies on certain data as close to that data as possible. And what I mean by that is that, again, this would work. We could totally do this. But it's nice if we already have on the shipping plan class, we already have the weight tiers we're going to need. We have the flat charge that we're going to need. We may as well just add another method onto the shipping plan class that's going to do the calculation. And that way, all we got to do is, if we call this like calc cost inside of here, then we could just take in this weight argument. and do all the logic here. And that's nice for maintainability as an engineer. Then you know, okay, this calc cost, it's related to the shipping plan. If you go to the shipping plan class definition, then you'll find this logic. And it kind of helps keep things a little bit nicely organized. So inside of here, let's initialize the cost at 0 at the beginning. And as we mentioned before, it looks like there's a couple different ways of charging. One is a price per pound, one is a flat charge, and not all of them have either one of those. So for example, we don't have any weight tiers when it comes to the premium shipping plan. And so therefore in the method that, again, in the standardized model, the first thing we need to do is check, do we have any weight tiers? Because if we don't, well, then there's nothing to compute as far as that's concerned. So if we check here first, if we do have weight tiers, then we're going to need to check which tier would this given weight fall under. And so if we take the example of the weight being like 3 pounds, and we could take a look at Sal shipping, and let's just go with where 3 pounds, I guess, would be this one. So we're going to want to loop through each tier in the weight tiers. So for tier in self.weight tiers, we're going to need to check if, and I'm going to put this in parens, and you'll see why in a second. So if the weight is greater than the minimum for that tier, so if 3 is greater than 2, and the weight is less than or equal to the tier.max, so if 3 is less than or equal to 6, then what we want to do is update our costs now to be this weight times the price per pound that we expect at that range. So in this case, it's going to be 3 times 3 would be $9. So we're going to do tier dot price, right, like that. And then since we're for looping, and if we did find the correct tier, we don't need to continue to loop to check the other items. We already found our answer. So we can go ahead and just break that for loop right after we found that. And so I mentioned that we put this in parens for a reason. And that's because we just took a look at kind of the easy example where we have both a min and a max. But we also need to account for some of these weight tiers do not have a min and they do not have a max. And if we were to compare, if the weight is greater than none or the weight is less than or equal to none, Python's going to freak out because it's like, I don't know what to deal with this. This is not a number. What's going on? And therefore, what we need to do is actually check first. The first condition we should check is whether or not tier is none. Or then we go ahead and compare it if it's not none. And so another way to think of that is if the tier is none, then we just skip it. So this would evaluate to true, and we can just check the next condition then. And similarly, if tier.max is none, or if it is therefore not none, then it needs to be less, the weight needs to be less than or equal to it. So cool. Hopefully that made some sense. And the next thing we have, we're halfway done on that. We just need now to check the potentially flat charge if it exists. So similarly, we would do if self.flat charge, then we want to update the cost with the self.flat charge. And by the way, I don't know, in case this is new syntax to you, the cost, we could do this. We could do cost equals cost plus the flat charge, but you can do a shorthand. If you do plus equals, that's saying assign the new value of cost to be itself plus whatever comes to the right of it. And in this case, we're talking about the flat charge. So, okay, cool. And then from here, all we have left is just to return the cost back out of this method, and we should be good to go. So now let's just double check that, which sanity check. So if we print out the ground cost, calc cost for our weight, which at the moment is 1, let's take a look at this chart first, see what we would expect to happen. So if we're calculating a ground cost shipping price for a weight of 1 pound, that would fall under the 2 or less tier, which means it's $1.50 per pound. So it's $1.50 plus the flat charge of 20. So if we run this, we'd expect to see 21.5, and fingers crossed, yes, we do. Okay, great. And now that we have our data model, we have our specific details, and we have a way to calculate the cost for a given weight, now we actually get to come to the final part of the solution, which is we want to know, out of the plans that we're aware of, in this case there's 3 of them, out of those plans, which one's going to be the cheapest. So we're going to need to first list out the plans we're going to compare against one another. So we've got the ground plan, we've got the premium plan, and the drone plan. This sounds like something we probably want to be sorting. We probably want to sort these by how expensive they're going to be, and we want the cheapest out of those. So let's make a new variable. We'll call this plans, sorted plans. How's that? Sorted plans is going to be equal to. And here, I think we could leverage a built-in Python function from the standard library called sorted. I have the documentation available right here for us to take a look at. And this should look pretty familiar. They're doing a similar kind of example here to showcase this, where we've got a class, a student class in this case. We've got a list of students that we've initialized. And then here's the sorted call. The first argument is going to be the list of stuff we're trying to sort. In our case, it's going to be those plans. And then the second argument is this key argument, and it's leveraging a lambda function. And if you haven't seen these yet, these are really cool. I'm a fan of lambdas. Another word for these is anonymous functions. And basically what they're doing is they're a way to define a one-line function, as opposed to the typical way in Python where you have to say def and the name of the function, colon, and then you indent and you go to the next line. Instead of that, you can use lambda functions in places like this. And so why are they helpful? Well, in this case, we don't really care about this function that's going to be returning the student's age. We don't really care about that beyond just as an argument to this sorted function. So because we don't care to keep it, this is like a one and done kind of a thing, then it's convenient for us to just keep this in a one-liner. And that's what lambdas and anonymous functions let us do. And so the syntax is you say lambda, and then you specify the name of the argument. In this case, we're going to call it student. And then after this colon, we then return out of this function what the age is on that student. And what this is doing then, since we're passing this to the sorted function, what this is saying is, hey, sorted, take this list of students, and for each of them, run this function, which in our case, again, is this lambda function. Run this function, get the output, and then using the output for each of them, those are going to be the keys that we're going to use to sort that list and put them in a specific order. So coming back to our code, what we want to do then, so we were sorted, we want to get the plans. We're going to sort those plans by, let's go ahead and use a lambda here as well. Lambda, we're going to call this, for each plan, we want to return plan.calcCost for the weight that we've entered, in this case, 1 pound. And then from there, now we've got our sorted list of plans. So these are going to rearrange the order. And we can go ahead and access the cheapest plan, we'll call this cheapest, by getting the 0th index of the list. And by the way, I should mention that by default, sorted is going to go from smallest to largest, and that's exactly what we want in our case. So we're going to get, by getting the first element out of it, we're going to get the cheapest plan. So now we can check ourselves again. We can say, okay, print, let's do cheapest.name, and it's also, I guess we're going to have to recalc this. We're going to do calc cost of the weight. And so since this is set at 1 pound, this should be the cheapest plan for a 1 pound package. And what we're getting out is drone shipping, and the price should be $4.50. So let's double check that too to make sure we're still on track. So let's see, here's the drone shipping. 1 pound is in the 2 pounds or less category. So 1 times 450 plus 0 for the flat charge means 450. That's correct. And let's compare that to the other plans. So that's a heck of a lot cheaper than $125 for the premium, as well as the $21.50 we saw earlier. So that looks correct. I think we are in good shape. So lastly, I think we could make this output just a little bit nicer, because right now drone shipping 4.5, that's not too helpful. I think we could do a little bit better. So let's say something like cheapest option for a weight pound package. And I'm going to leverage Python's formatted string here. So I'll put an F in front of the quotation mark, and then instead of here, because we use curly braces, that's telling Python, hey, take the variable that we defined as weight. In this case, it's a number. Go ahead and take that variable and convert that value into a string, which means we can then include it in our text output to the terminal. And I'm going to also move these to another line. So we're going to say, okay, the cheapest option for a pound, for a like 1 pound package, 2 pounds package is going to be print. And we'll do format again. We want to know the name of the company. So we could do company is going to be cheapest.company. And let me copy this whole line. This is here. Company, plan name, cheapest.name, and the price. Total, or I just want to say total cost. How about that? Total cost. And do calc cost of the weight. And this could be US dollars. There we go. We'll run this. Okay, this is looking a lot better. Cheapest options for a 1 pounds package is going to be Sal shipping, the drone shipping option from Sal, and total cost $4.50. Now, a couple little things I think we can improve here. One being, you'll notice that we're calling calc cost twice. And that's not too efficient, because if we come back up, take a look at that calc cost function. That means that we're running this logic twice. And that's not great, because once we run it once and we get an answer, that answer shouldn't really change. We're not updating any other of the data, so the answer should stay the same. There's no reason for us to instruct Python to run this code again. We could just store the output and reuse that instead. And so I think what we could do is, I'm just going to be a little bit explicit here and come back up to the init method for shipping plan. And we can attach it right on here. Why don't we just say cost, and we're going to start out with none. But whenever you calc the cost and you give it a weight, we can go ahead and save that value here. Right before we return, we can just say self.cost is going to be equal to this cost variable that we've added the dollar amounts onto. And then we still do need to return, because if we come back down here, we need to, this lambda function needs to return back out something that's going to be used by sorted to know how to rank them. So we still need to return, but now all we have to do down here, instead of running this method again, we can just access cost just like that. And if we run this, we get the same output, and yet this is going to be way faster, because now we're just looking up the value that we've stored as opposed to recalculating what the cost is again. Cool. So one last thing I think we can do to make this just a little bit nicer is, right now we're saying $4.50, but we're not saying 50, we're saying 0.5. And that's because by default, we're dealing with just regular numbers, and 4.50 is kind of extra bits of data to be showing than it is 4.5, because mathematically those are obviously equivalent. But when we're printing them out and we're talking about dollars, we definitely wanted to say 50. So to do that, I also have some documentation over here for the using formatted string literals. We have this example where we're printing out the value of pi, and we want 3 decimal places to the right. To be printed out, and so that's what we can use here. If we use this :3 and then f float, we can come back here, and in our case, we don't want 3 decimal places; we want 2. We want to say 0.50. So if we run this one last time, now that looks good. That looks like what we want. Okay, and so that's basically it. And we can double check ourselves one last time. I guess triple check this. I think down at the bottom, they give us some example values we can plug in, and we can check our answers against the solutions there. So we did 1 pound, let's update this, let's try 4.8, and we run that. It's telling us that the cheapest option for 4.8 is going to be Sal's shipping, ground shipping, and $34.40 would be the price. So if we double check that, yes, ground shipping should be the cheapest at $34.40. There we go. And the other one try is $41.50. $41.50 and 41.5, whatever, that works. Run that. Cheapest should be the ground shipping premium at $125, and that is correct. Ground shipping premium at $125. Perfect. So there you go. We've just coded up an alternative solution to this project, and one that is more scalable, in that if we had data from other companies, we could enter them into our standardized data format here, and we could include them in the comparison to know which one would be the cheapest. So one thing else I'd like to mention about this is that this is a little bit closer to what you would find in a real-world application, because regardless of how in a real-world scenario we would be getting this data, we could end up with classes to represent them. And what I mean by that is, maybe one option is, let's say we had our own in-house database where we collected all of the payment, all of the different shipping options from these various companies, and we stored them ourselves in our database, and then our application that would power our website would be looking up that data. Well, in that case, there are Python libraries you can use that can translate data coming from a database into these class representations. Like one example being like an ORM, like Django is a popular web framework, and there's an ORM for that you can use, which translates sort of for you. You give them the Python class definitions of your data, and you connect that with the database, and it handles the translation for you. Or another option is maybe instead of us having a database, maybe we end up calling out to across the internet to the websites for Sal's shipping or any of Sal's competitors. And when we talk to their data, we get the data from them live. We talk to their servers live to get that. We again could make these HTTP requests, and then when they come back in, we could have some code that would translate them back into these classes. So the point being is that in our example, we initialize them ourselves by hand because we're not dealing with a database. We're not making any network requests at the moment. But our code is still closer to something that you might see, again, in real life, in a real world application. You would be dealing with classes. And once they're in a class, the rest of our logic would work just the same. All right. Well, hey, thanks for coming along. We hope this video was helpful. If you'd like to try this project on your own or check out some of the other projects we have, or if there's anything we covered in this video that you'd like to learn more about, go ahead and check out the link in the description below. Also, if you enjoyed this content and would like to see more videos like it, feel free to subscribe to Codecademy's YouTube channel, where you'll be notified whenever new videos become available. With that, thank you, and see you around.